this in case people want to, in case they want to watch it later. All right, so here, Mike, yeah.
Yes, go ahead. Go ahead.
No, so I just wanted to share that we have our uh, week 24 data set for this Figure Friday session. And we have the data set is called Open Parking on Camera Violations, which um, includes also places in not only it's from the New York City Open Data Portal, but it also includes camera violations and parking violations in other states, but mostly in New York State. Is that what you found also in your data exploration, Mike?
Yeah, yeah. That's what I wanted to do also, and see what the fines are. That was one of the categories I outlined. Maybe see what the fines are for New Yorkers who live in New York, as opposed to out of state. That would be a nice comparison as well.
Yeah, yeah,
Um,
that's a good point.
you
That's a
can't
good insight.
you can't compare, since a lot of them were bulk were in New York. So you want to compare apples to apples, and
Yeah,
if you're going to compare the out of state ones, then compare all those together.
yeah, that's a good
There
point.
was some very good ones. I was looking on the forum, and there was some very good ones. Esther, of course, had a good one.
Yeah,
Very
let's look at
professional, polished.
completely. Let's look at Esther's right now. So these are just sample apps graphs that I provided at the very beginning of the post, which is just a dash AG grid and a bar chart. And then a bunch of community members have posted really nice graphs and apps. This community member, Lisa, actually came to the New York City meetup, the New York
Mm.
City Plotly meetup last Monday, or this Monday that just passed, and she fiddled around with a data set and Plotly, and then she created this pie chart just as an example because she doesn't have any experience with Plotly, or very little. So I'm glad she was able to post something. Let's go all the way to the end. You mentioned Esther. Uh,
Very
did,
polished.
did
Uh,
she
you
already
know,
share the Pi Cafe link? There we go. Okay. So we're gonna see Esther's app on Pi Cafe. Soon we will also have Plotly Cloud, which will allow us um, to build apps low, well, not low, but to share the apps um, if you're on a certain tier. But let's look at this Pi Cafe. Okay. Did you said it was a beautiful? I agree with you, Mike. Did you want to comment on something specific?
well, just the color scheme, of course. Even something as simple as the rounded corners instead of square boxes. It just looks really beautiful.
On
And I
the
like the
card?
angle. The angle labels on the first one in the bottom. You see the x-axis.
All right, here.
Violation by type, types by count, and then you can easily read those. They're on an
Yeah,
angle, beautifully done. Much easier to read, and this way you can fit them in because they are quite long.
I agree. I agree. It's a great usage instead of just horizontal. Sorry, vertical. Um, I mean, yeah, I like how in the cards here she curved them. It looks more modern. It's hard to see in the dark, but if you really look closely, you can see these are Alex from Venezuela. He builds a lot of these kind of summary cards, which are very beautiful, and Esther doing something very similar here. So you can see there's 16,000 unique plates, which probably means no, not necessarily, because the row, each row is a violation. So you can see here in the data set, each row represents a violation and a fee. So I'm just thinking if there's 16,000 unique plates, some of them obviously receive 2 or 3 violations because you have more.
Repeat offenders.
And that would be interesting to see how many repeat
Yes.
offenders we have. Um, Total fine amount $3 million, an unpaid amount. That's well. I think this is the data set is older. If it was a present data set, this would be very um, abnormal because this looks like the 95, 99% of the fines were paid, but that's only because this data set is older. This data set is from 2023 that I filtered out, since the larger data set was a lot bigger. And then we have the heat map that you created
That
here.
heat map is really nice. Beautiful.
Yeah, let me see if
Perfect
I can.
application.
Violation heat map by day and hour. Yep. Esther did a really good job here. A very appropriate graph or chart for this type of data. Day of week, Sunday, and then we see the violation hour. So you almost never get violations after 10 o'clock at night, between 10 and 5 p.m., at 10 o'clock at night and 5 a.m. But you can see here that the high bright yellow is at 9 a.m. on Fridays, and really Fridays, right?
A big 9 a.m. block. Yeah,
Big
definitely.
9 a.m. all day.
All week, but specifically on Friday.
Yeah, same thing with 2, 3, and 4 p.m.
The afternoon.
After lunch, you get a lot. But specifically on Friday, there's a lot, or Tuesdays for some reason, at 2 at 5 p.m. Interesting. So we have this, and then I think there's multiple tabs here. Well, we can filter. We just want to see Florida. Let's see here. Big difference. Friday is not as an active day as, or 9 a.m. is not as active as the later hours when compared to, maybe we'll compare it to New York.
That was New York, probably, right?
Yeah. New York is 9 a.m. I think I did all states, and Florida is, you just wake up later. And then we have state status and amounts as a second tab. Let's just do all for the drop down. And here too, we have a nice donut hole in this pie chart with the violation status distribution. We see that 36% come from hearing. Whoops. Yeah. Hearing held guilty reduction. 35% from. I'm not sure what this means actually. Did you see this in the data set?
I can't quite see it. Let me make the screen bigger. Okay. Well, these are all I seen this column. This column also was interesting for me as well to understand. Hearing held guilty, and then hearing held guilty reduction.
Well, I found guilty, but what's found guilty reduction? I guess to reduce the fee.
Yeah, and that was interesting that it was more. So does that lead you to believe that you should go to court and at least you can get it reduced?
Yeah, probably. It's a good conclusion.
Maybe. Hearing held not guilty. So that was it. I was struggling with this one also. How do you display something like this? The labels are big. There's what is it? 10 labels.
Yeah.
10, 12 labels. What format do you use to display something like this so that it's visible and not overlapping and too crowded as well? This is a good use of that. Very good use.
And then we have your fine amount. This is a scatter plot. Correlation between the fine amount of the x-axis and the amount due on the y-axis. So for example, here the fine was 250, but the amount due was 95, suggesting there's a lot of reduction, like we see here, after they go to court, or discount, whether they go to court or not, they'll find a discount here.
Yeah, so, this one I didn't quite understand as much.
I mean, I understand that there's a correlation here between fine amount and amount due, because the higher the fine, the higher is the amount due, right? Because I don't know if this scatter plot is the best or the most appropriate graph for this type of correlation, because amount due and fine amount, we know it's going to be correlated to some degree, because if I owe $1,000, I'm gonna that's the fine. The amount that is due at the end, if I get a discount or whatever, is going to be probably close to $1,000, and if not, it's going to be $500. Let's say it's 50% off, which is big, right? Oh, $500, but that's still highly correlated. It won't be minus. It won't be above $1,000. It'll be close to $1,000. And the other person that has a fine will probably maybe get the same discount or more or less the same kind of reduction, whether it's 100 and it'll get reduction to 50, but still the higher the fine, the higher the amount is going to be due. So I think that we should probably consider using a different graph here to see.
Maybe the point was to show the outliers here, the
Okay.
unusual ones.
Like these.
Yeah.
These had to find that all of them were just, I guess, forgiven, or the person was found not guilty. This could be the 15%. We just highlight the 50. Well, highlight the 50% of not guilty would probably be here. All the x-axis on the y-axis would be 0, where the amount due is 0. That could be it. Yes.
And the one other thing might be interesting here that would help is a count. A count to understand how many of those there are.
Oh, true.
Then you would understand the if it's a significant amount or not.
And if we double click on the legend, that's why I like about plot. If we double click on the legend, that will give us a better, easier to grasp information or data storytelling here. Let's say not guilty, right? Not surprising. All those that are not guilty, amount due are 0. The fine could have been 600, but the amount due is 0 because they were found not guilty. Or we can double click on held guilty. All right. So even though they were guilty, there is, like you said, the abnormal numbers, the outliers here, still exist, right? There's 1, 2, 3, 4, 5, 6, 7, 9, about 10 or 11 that were held guilty, but yet were given no fine, right? Or the amount.
Each individual, that's one specific case.
I think so, yeah.
Oh, okay. Okay, and depending on the region that we chose, I got it.
But that's interesting because $650 was a fine. I was found guilty, yet the amount due was 0. So it's interesting what kind of decisions the judge make.
Maybe a bubble chart would be good too, and it would show the size. That would show the count then better.
Oh yeah. Agreed. A bubble chart would be good here. Here I was found guilty with reduction, but I'm almost seeing the same ones. Maybe the data was not plotted here correctly because the held guilty with reduction and not guilty and guilty all have the same, at least in the y-axis, the same colors.
Maybe some data was missing or something. So
maybe, or some might be duplicates. Like this one right here seems like it's a duplicate. 115, 125. Now I have also not guilty. 115, 125. It might be a duplicate, or maybe a lot of the amounts are very similar, or actually the same. There's not like 124. There's not like 131 or point. It's not a float. It's all either 115, 125. So I think you're right. Like a bubble chart would be very helpful here to see the size of each one of them. Okay, so this was the second one. Tab. The last tab is a data table that Esther put together, which is actually the -AG grid. And we can move things around. We can here we have filter. I think we only chose all states, so we can say instead of using the drop down here, we can say equals, what was it, New York? Only New York, which will not, unlike the drop down, won't filter the cards because that's the purpose of the drop down, but it will filter the -AG grid to only those rows. So we have 22,000 rows. But if we do not say we're not equal New York State, Let's see. Now we have 3,300, so we know how many are not New York State. 3,000.
Hmm.
Really cool. I like what Esther did here.
Which one did you say this is called? This
Dash AG
table
grid.
AG grid?
Dash AG grid.
Dash AG grid. Uh-huh.
Yeah. So AG grid is actually the software itself. It's a company that built AG grid, and it's with JavaScript. They tout it as the best JavaScript table out there. And so we wrap it in Python, and we use it as Dash AG grid, and you have almost all the functionalities available inside Dash.
Okay. Yeah, it looks very
Yeah, Esther did a really good
easy
job
for
here.
the user.
What?
Easy for the user friendly.
Yeah. For people who are in the Python ecosystem and not JavaScript, they can take advantage of that beautiful product they have. I did want to give a shout out to Lee. Lee is great, Mike. I don't know if you met her. She works at Vizdro, and she's a database expert, and she always gives whenever she can. She doesn't do this every Figure Friday, but whenever she can, she comes in here and she gives really good advice on the dashboards that people provide on how can one improve the storytelling, design, layout, themes, and database in general.
Yeah, I noticed that. Some pros, some cons, and yeah,
Yeah,
that was very interesting, very
yeah,
helpful for people.
yeah. It's good to connect with her. And then we have you, Danny, who built. Oh, I love this parallel coordinates chart.
This is what is it called?
Parallel coordinates.
Parallel coordinates. It's very definitely intriguing.
Yeah, it's beautiful. I mean, he just put here an image, but parallel coordinates is a really cool chart when you get it to work, because you can look at it. Parallel coordinates plot. You can do so much with it. You can actually move, select only those that you're interested in viewing. Oh, oops. Could be I'm on the wrong browser here. I have to update my browser. There you go. See, I'm just interested in viewing these. Then I did that. Or I just want to see the sepal width between 4.4 to 4. So I just view those.
Mm-hmm.
Really cool. And then it shows you all the rest where they end up. And the sepal width is 4.4. Usually the petal length is very small, an inverse relationship there.
Interesting.
I love the parallel coordinates chart.
Quite unique. Yeah, unique. You have to make sure that that's appropriate use for your use case.
Yeah, you're right.
So here he's got find amount, penalty amount,
Interest.
interest. Okay, and reduction,
Reduction,
and then payment.
and then the final payment. It's interesting. The penalty amount is always almost 60, because there's only like 3 categories: 25, 30, and 60. And it seems that although, yeah, it's hard to tell with this graph, because you see, it almost seems like there's many more interest amounts and many more payment amounts violations than the fine amount. But that's because there's only a set number of fine amounts, right? There's only, I don't know, about 20, for 350 for parking your car wrong, some kind of camera violation in the stoplight, $200. So there's actually a lot more here, but they're categorized into fewer groups, so it seems like there's few, right? And then after including the penalty, the reduction, the interest amount, the court, what they decide, the payment amount can be very, very varied, right? So it could be like 225, 226, 350, while the fine amount is always very set. So I wish I could play around with it. I don't think he put anything on. Oh, did he? Yeah. Oh no, he just put the code for nothing. And did you see this one that Alex built?
Yeah, another fun one.
That's really amazing.
Very creative.
Very creative. He just made a game out of it. Let's see. Let's see while it loads. I wonder, Alice, if you see this video later, the recording, let us know how long it takes you, because this is absolutely amazing. Real data 2023. And you can spin the wheel.
Yeah.
To see what happens if you get into that fine category. So you spun the wheel. I'm a $650 fine, which I think is the biggest fine. 50, 250. It's not even here. Oh yeah, here. 650. There's about 91 in 2023. Well, the probability is less than 1%, and I got it in the wheel. Oh, cool.
You lucked out.
I know. And then it explains everything here. Do you see this, Mike? Like the violations, nice summary cards, summary information in the cards of what this usually means. 14%. This is so interesting. 14% of all those that receive 650 achieve discounts, which is interesting. I mean, this is more like a game, but if I had a violation from the city, and I would just spin the wheel until I got that, or maybe it was a drop down or whatever, or reached that violation, then I would want to see if I actually got $650 for, I don't know, running through a red light or whatever that is, then what's the chances I achieve a discount? Because then it was help me decide, should I go to court or not? What is the average discount? I mean, 454, that's a big discount. I might take my time and go. Risk level low.
Yeah, lots of wonderful statistics on each one of these.
Yeah.
Calculation, formula for each one of them, and in a placeholder somewhere, on this page here.
Yeah.
It just updates.
And here we can see, what is the calculator? I forgot to look at this calculator. Annual cost. Expected annual cost, 1,920. How many tickets per year? 15. Range. Okay, so if I receive 15 tickets per year for $650, this will be my range. High risk.
Mm-hmm.
Very interesting. I like it. Especially if it's a small iPhone. Shoot, I lost like one iPhone. Anyway, so here's his dashboard. We can always go to the editor part, and we can see this section right here. This is all the code that we can, if we wanted to copy or just fork it, we can just use this code. All right, folks. So this was this week's Figure Friday. Again, plenty of data sets. If you want to discover more, just go. I'm going to click the link here. And you can go under the video description and look into more of these apps and graphs. I'm going to put week 24 challenge. We'll share it here with everybody. Perfect. So now you should see it in the video description. And for our next Figure Friday, we have week 25. And it's going to be on a data set about building approvals in Raleigh. And we're going to do this in Raleigh. Mike, I chose actually this one because Raleigh is going to be our first Plotly. We want to have our first Plotly meetup in Raleigh, North Carolina on Wednesday the 25th. So they're going to use this data set as well. And to support them, we made it Figure Friday. Interesting data set with old building permits. Not all. The last 180 days of building permits in Raleigh and around the city.
It should be interesting. Yeah. See what kind of information you can get from that, kind of insights.
Yeah. A lot of the dates, contractors, addresses, how much it costs to do it, what are the fees and stuff like that. Anyway, folks, take a look. Join us. Build more graphs and dash apps, and join us next Friday at noon Eastern time to talk about the graphs and receive feedback on what you build. Mike, I hope you get to build something for next week.
Yeah, hopefully. I'm still challenged with time this week. Hopefully next week I'll be able to. I focus on little steps, little
Yes,
things.
that's
Not
good.
like Esther's, of course, but I'm trying to just gain one little part at a time, improve one thing at a time.
Go. All right, Mike. Thank you, and thank everybody for joining us and watching us. I'll see you here next Friday.
Okay.
Bye, everyone.
See you. Bye.